So today I wanted to go over kind of what forensic science is. Forensic science is science and how that applies to the law. So the application of science to criminal and civil laws that are enforced by the police and agencies in a criminal justice system. So there are many different things that we actually study in forensic science. It's not just one concise field. It's many fields combined. It's normally referred to as criminalistics. But with forensic science, we use chemistry, we use biology, we use physics, we use geology. All of these, you don't normally go to college to get a degree in forensic science. You get a degree in a field that you want to be in, and you apply that field to law. So you would study a whole lot about maybe biology, or even in a specialized field under biology, like entomology, where you're studying bugs and how they develop. And you would use that to solve crimes. The development of forensic science was actually a really long process. Sir Arthur Conan Doyle, he popularized physical detection methods in a crime scene by making storybook characters. For example, Sherlock Holmes. So this is an excerpt from his book called A Study in Scarlet, in which they are actually talking about how, like, different parts of your blood and how that can be different tests that they can use for blood stains and that kind of stuff. So this was used to kind of popularize crime detection, which is kind of cool. So this guy was a father of toxicology, which basically detects poisons. It's to detect if there's something toxic in somebody's system. So whether or not somebody had been poisoned or accidentally encountered something that would kill them. And then there's Alphonse. He is the father of criminal detection. He devised the first scientific system of personal identification, which it was where they actually measured your body parts to determine your measurements and how that would affect what you would do. So, and also to identify you. It turned out it wasn't as quite as effective as they had hoped. They thought, like, nobody's fingers are the same size. Nobody's fingers, arms, legs, and feet are the same size as someone else's, and it turned out that that actually can be true. You can have the exact same dimensions as another person. So it was not 100% effective, but it did help a little bit. And then there's Francis Galton. He conducted the first study of fingerprints, and he wrote a paper on it entitled Fingerprints in 1892, in which he discovered that they were all unique and there were different parts of them. And then there's this guy who determined the different types of blood type of a dried blood stain. So he used a method to determine whether the blood stain was A or AB or B or O blood, just from a dried blood stain. So that turned out to be really helpful, and they still use it today. Then we have Calvin Goddard. He used comparison microscope to determine if a bullet was fired from a specific gun. So he was pretty brilliant, and he found out that every gun has its own firing pattern and therefore its own markings on bullets, and we still use this information today as well. So it's called tool markings on bullets, and it's really kind of neat to go through and determine whether or not a bullet has been fired by a specific gun. So Albert Osborne developed the principles of document examination. So basically what this is looking at different papers and seeing if they were written and or printed by certain people, handwriting evidence, that kind of stuff. He was responsible for the acceptance of documents as scientific evidence by the courts. So Edmund Locard, he demonstrated the principles by Hans Gross could be incorporated into a crime lab. And he demonstrated very well Locard's exchange principle, which states that if you touch something basically with something else, then there's going to be a material transfer. So these guys kind of set the foundation for forensics, and then since then the number of crime labs have increased as courts have actually demanded more secure, scientifically evaluated evidence. So more crime, more drug-related crime, the greater need for physical evidence, the greater use of DNA profiling. There are major crime labs in about every really, really large city. Approximately a couple per state, but some states don't even have one. So many local crime labs have been created just for the purpose of processing evidence. Most of their energy and funds are used to analyze drugs and DNA. In 1932, President Hoover established a National Forensics Laboratory to support all law enforcement in the U.S. The oldest American forensics laboratory is in Los Angeles, created in 1923. And there are different types of areas in which a forensic specialist would work. You could be in physical science, in which you would do like the trajectory of blood spatter and possibly maybe bullets and that kind of thing. Biology could be anything to how something decays to what kind of toxicology would be in there. Firearms would be identifying gun markings or tool markings on a bullet. Identifying handwriting. Photography would be, being able to break down and look at certain parts of a picture. Toxicology would be looking for poisons, and then we have fingerprinting, which we're going to get into shortly, lie detecting on our polygraph, and then voice imprints and other different sorts of evidence. So the physical science unit, this kind of breaks it down. Anything to do with chemistry, physics, geology, the identification and comparison of crime scene evidence. Biology would be blood stains, bodily fluids, hairs, fibers, botanical materials like wood. And then we have firearms, in which we would look at cartridges and bullets and shotguns. And then document examination would be handwriting, paper, and printers of documents. Photography looks at physical evidence of the crime scene and suspects. Toxicology would be body fluids. And then drugs and poisons. And then we have latent fingerprint unit, which examines the use of fingerprints found on surfaces. And then the polygraph, which is a lie detector. And then voice print is involved in cases of telephone threats or tape recorded messages. And then we have the evidence collection unit, which actually goes to the crime scene and collects the evidence and ensures it's all taken care of properly and brought back to the crime lab. So there are many different levels of forensic science. So a person generally has to be specialized in that specific field in order to apply forensic science as well. And then an expert witness is a witness that possesses a particular skill or has the knowledge in a trade or profession that will aid the court in determining a truth. That is the type of witness a forensic scientist would be in a court case. Specifically trained evidence collection technicians are the people who actually go out into the field and preserve the evidence and bring it back to the medical examiner or coroner to determine the cause of the death or autopsy. And then forensic pathology would be the study of what caused death, which would be a coroner, somebody who actually studies why somebody died. They would perform autopsies. After a human has died, they go through several stages of death. So the muscles, following death, the muscles relax and then they become rigid. That's called rigor mortis. And then you have livor mortis, when the human heart stops pumping and the blood actually settles into the parts of the body closest to the ground due to gravity. And so the area that's closest to the ground will appear purple. And then you have algor mortis, and this is in which the body temperature continually cools and reaches room temperature, enabling the medical examiner to establish the general time of death. So, forensic anthropology involves the identification and examination of skeletal remains in order to determine if they're human or animal, or what killed them, what age they were, what kind of manner they died. So this would be like what Bones did. If you ever watched the TV series Bones, this was her job. She was a forensic anthropologist. And that's not really the same thing, because people as like CSI, because the people that have died in the CSI shows have died recently. It's not over a long time. And then there's forensic entomology, and this is a study of insects and their developmental stages. And people use their developmental stages to actually determine how long somebody has been dead, because the bugs will show up in a certain amount of time after death and get into the body and start eating away at the remains. And then we have the forensic psychiatry. This is a study of human behavior. This, while it can be very important, it can also helps a great deal with people who have behavior disorders, and when they're trying to just figure out who committed the crime, like what kind of person they would be. Then we have forensic odontology. So these are like dentists, but they work with matching bite marks to suspects' teeth. Forensic engineering is used to analyze construction accidents or causes of fires. Basically, like a building falling down or that kind of thing. And then organic analysis is going to include things like chromatography, which we will actually do. And here, UV visible or spectrometry, mass spectrometry, that we won't be able to do because we don't have the cool machines to do it. Organic analysis, such as the emission spectrum of elements, atomic absorption, spectrophotometry, sorry. Took a drink of my orange juice there. But there, as you can see, there are many different fields, and it's not limited down to forensic science. Forensic science is this great big thing, and you have to be very specialized in a very specific area in order to function within a forensic team to actually perform a lot of these analyses. And it's very important that you realize that this takes time. It's not like CSI. it actually takes a great deal of work. I hope you enjoyed this. I hope you have fun with forensics.